Hello and welcome to Lucid Mind. I'm Majid, and in today's video I'll go through solving of multiple choice questions, Paper 1, Variant 2 from March 2020. If you want to go to a particular question, just follow timestamp in the video description. Let's begin.
Question number 1. What number of protons, neutrons and electrons are present in the ion Fe plus 3? Now the atomic number is not given, so we will be consulting periodic table. So from the periodic table we come to know that the atomic number is 26. Mass number is 54. So the number of protons is 26. Number of electrons, as the charge is plus 3, so it means 3 electrons are lost. So it is 26 minus 3 equals 23 electrons. And neutrons, for neutrons we have to subtract mass number and atomic number. 54 minus 26, the answer comes to be 28. So now it means that the answer is A. Second question, for which hydrocarbon are the molecular and empirical formula the same? So molecular formula is something that gives the actual ratio of atoms, and empirical formula is the one which gives the simple ratio of atoms. So first one is butane. The formula for butane is C4H10. This is the molecular formula. So if you are going to simplify the number of atoms, it comes to be C2H5. For ethane, there are 2 carbon atoms, C2H6, and the simplified formula is CH3. For pentene, pent-1-ene means the double bond is on first carbon atom. So as it is an alkene, there are 5 number of carbon atoms and 10 number of hydrogen atoms. The empirical formula is CH2. For propane, we know that there are 3 carbon atoms and 8 hydrogen atoms. Now this ratio cannot be simplified further, so the empirical and molecular formula are same. So it means that the answer is D. Question number 3. Which molecule does not have any 90 degrees or 180 degrees bond angles? Part A is C2H6, which is ethane. In ethane, carbon is making single covalent bonds. Each carbon is making 4 single covalent bonds, so the bond angle is 109.8 and the structure is tetrahedral. B is carbon dioxide. Now the bond angle in carbon dioxide is 180 degree because the structure is linear. C is phosphorus pentafluoride. Now in phosphorus pentafluoride there are 2 different types of bond angles which are present. 3 of the fluorine atoms are in the same plane while 2 are not. So the bond angle here is 120 degrees and this one shows the bond angle of 90 degrees. D is SF6. So in SF6 bonds are like this, 2 fluorine atoms. Four fluorine atoms are in the same plane. So the bond angle is 90 degrees while the one above the plane and below the plane also has an angle of 90 degrees. So the answer is A. Question number 4. The following data are needed for this question. Now 2 different types of enthalpies are given. One is of sodium bicarbonate. Second is of sodium carbonate. Both are reacting with HCl. On heating, sodium hydrogen carbonate decomposes as shown What is the enthalpy change for this decomposition? So we have to find the enthalpy change of decomposition. As 3 different reactions are given, so we can use Hess's law. So writing the main equation, we have 2NaHCO3 solid gives sodium carbonate solid along with water liquid and carbon dioxide as gas. Now NaHCO3 also reacts with HCl and forms HCl and forms sodium chloride along with water and carbon dioxide. Similarly, sodium carbonate also reacts with HCl and forms the same product. We just have to balance sodium. Now it is balanced. Now let's see, according to Hess's law, which is one-step process and which is two-step process. If this is the reactant, and this is the final product, so this is going to be A, and 2 steps are involved here, so this is going to be B and C. So according to Hess's law, A is equal to B plus C. Now we have to find the enthalpy changes in A, B and C. 2 NaHCO3 are giving 2 NaCl and water and carbon dioxide. So 2 moles of NaHCO3 are involved. So taking value from the first equation, we have sodium carbonate with HCl and the enthalpy change is minus 38.97. So as 2 moles are involved, it will be 2 into minus 38.97. It comes to be minus 77.94. B step is something that we have to find out. C is also given in the question. Sodium carbonate plus 2 HCl gives minus 96.59. So C is minus 9659. Just putting the values that we have. Minus 77.94 is equal to B plus minus 96.59. So B is equal to minus 77.94 plus 96.59, and therefore it is 18.65 kilojoules per mole. The answer is positive, so it is C. Question number 5. In the redox reaction, shown how the oxidation states of vanadium and sulfur change. So they have given us 2 elements and we have to find the change in oxidation states. First, finding the oxidation state of vanadium in VO2+. So vanadium, as oxygen is in group 6, so it has a charge of -2 and there are 2 oxygen atoms, so 2 into -2. And the overall charge is +1. So V minus 4 is equal to plus 1. So V is equal to plus 5. Now the answer could be C or D. Finding the oxidation state of sulfur in SO2. Again we have two oxygen atoms, so sulfur minus 4 and the overall charge is 0. Sulfur is plus 4. Now the oxidation state of vanadium in the product is plus 3 and oxidation state of sulfate, sulfur and sulfate ion can be found like this. Sulfur, there are 4 oxygens, so it will be minus 8 and the overall charge is minus 2. So sulfur is equal to plus 8 minus 2 and plus 6. So it is obvious that the answer is D. Question number 6. The equation for the reaction between silver chloride and aqueous ammonia is shown. What are the units of Kc for this reaction? So we have to find the units of Kc. As we know that Kc is the concentration of product divided by concentration of reactants. So this is one of the product, chloride ion is another product, and the reactant is silver chloride solid and ammonia. All have their powers equal to the number of moles. As silver chloride is solid, so it does not have any concentration unit. The concentration is only possible for aqueous solution, not for solids. So as we know that the unit is mole per decimeter cube, ammonia has got 2 number of moles, so we squared this one. Now all of them will be cancelled out and there will be no unit left behind. So the answer is part A, no unit. Question number 7. Sodium azide Na(N3) decomposes as shown. They have given the equation. Which volume of nitrogen measured at room temperature and pressure will be produced by the decomposition of 150 grams of sodium azide? So sodium azide decomposes to give sodium atoms and nitrogen gas. So first we are going to find the ratio between the given components. So Na(N3) and nitrogen. According to the balanced chemical equation, 2 moles of Na(N3) produces 3 moles of nitrogen. Now they have given you the mass of sodium azide. So first we have to find the moles of sodium azide, as moles is equal to mass divided by molecular mass. So mass is 150 grams. Molecular mass of Na(N3) is 23 plus 3 into 14. So moles is equal to 2.307. So if 2 moles of sodium azide produces 3 moles of nitrogen, so then 2.307 moles of sodium azide will produce X moles of nitrogen. Cross multiply, find out the value of X. So it is 2X is equal to 3 into 2.307 divided by 2. So X is equal to 3.460. Now this is the number of moles of nitrogen produced from 150 grams of sodium azide. But they have asked about the volume of nitrogen, not the number of moles. So we know the formula of volume is moles into 24 decimeter cube. Why have we chosen 24 decimeter cube? Because they told that this reaction was occurring at room temperature and pressure. If it was standard temperature and pressure, we should have taken 22.414 decimeter cube. So now 3.460 into 24, volume comes to be 83.05 decimeter cube. So the answer is part B. Question number 8. A stable ion N5+ has been produced by research chemists. Which structure is most likely to show the electron arrangement of the ion? So it says that the N5 is stable. By stable, we mean the octet should be complete, so there should be 8 electrons around the nitrogen atom. So in A part there are 5 nitrogen atoms, and while counting the number of electrons, we have 1, 2, 3, 4, 5, 6 electrons. So this does not seems to be the stable arrangement. Coming to part B, nitrogen has 1, 2, 3, 4, 5, 6, 7 electrons. So again, this is not octet configuration. Part C, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So yes, C seems to have the complete octet. So now finding out the next number of nitrogen atoms, we have 1, 2, 3, 4, 5, 6, 7, 8. Yes, good. The next one is 1, 2, 3, 4, 5, 6, 7, 8. Again the octet is complete. 1, 2, 3, 4, 5, 6, 7, 8. And the last one, 1, 2, 3, 4, 5, 6, 7, 8. So yeah, all atoms have complete octet, so the answer is part C. Question number 9. 1.8 grams of water heated to 227 degrees centigrade in a sealed container turns to steam with a pressure of 200 kilopascals. What is the approximate volume of the container? Question number 9. 1.8 grams of water heated to 227 degrees centigrade in a sealed container turns to steam with a pressure of 200 kilopascals. What is the approximate volume of the container? So now we'll see. This is from gases. So we are going to use the ideal gas equation. PV is equal to nRT. P is the pressure. Pressure should be in pascals. V is the volume. Volume must be in meter cube. N is the number of moles. R is the ideal gas constant, and T is the temperature. Temperature should be in Kelvin. So first, finding the number of moles. 1.8 grams of water means 1.8 divided by mR of water is 18. So it is 0.1 moles. 227 degrees centigrade is the temperature. So converting this into Kelvin, we have 227 plus 273 and it is equal to 500 kelvins. Pressure is 200 kilopascals, so we can also write as 200 exponential 3 pascals. Now we have to find the volume. Simply putting these values into the equation. So we have volume is equal to nRT divided by P. Putting the values, volume is to be found, number of moles is 0.1 moles. The value of R can be seen from the data booklet, it is 8.31. Temperature is 500 Kelvin and pressure is 200 exponential 3 pascals. So calculating this, the value of V comes to be 0.002 meter cube, which can also be written as 2 exponential minus 3 meter cube. So the answer is part B. Question number 10. When the equation is correctly balanced, what is the value of C? So they have given you A, B, C, D, E. So many values are not given. So what does the balanced chemical equation means? It means that the number of atoms should be balanced on the reactant and product side, and also the charges must be balanced. Charges means that the positive charge and the negative charge on both sides of the equation should be equal. So as we know that there are 2 manganese atoms on the reactant side, so we can balance the manganese ion by writing 2 in the place of E. Writing the chemical equation again, we have C2H4 plus H2O plus H plus 2MnO4 minus gives C2H6O2 and Mn plus 2, which is 2. Now finding the charges on each of these molecules or compounds, we can see that C2H4 is neutral, so the charge is 0. Overall charge is 0. Similarly, H2O is neutral, so the overall charge is 0. H plus is positive, and we have to find the number of moles. So let's suppose it to be X. Then we have 2 manganate ions, MnO4 minus. We have already balanced this one. Now the negative charge is, there are 2 MnO4 minus ions, so it means that the negative charge present on manganate is minus 2. For 1 manganate ion it is minus 1, and as there are 2 moles, so the charge is minus 2. Now on the product side we have C2H6O2, which is neutral, so the charge is 0, and Mn plus 2, which are 2 number of moles, so the charge is plus 4. So we have the equation x minus 2 is equal to 0 plus 4, or x minus 2 is equal to 4, or x is equal to plus 6. So this shows that the charge on hydrogen atom should be plus 6. So as we have 1 hydrogen atom, there must be 6 hydrogen atoms, so the charge should be plus 6. So now there are 6 H plus. So C is 6 What is the value of C? They were asking about the value of C, so yes, now the answer is 6, as the charges are balanced on both sides of the equation. Question number 11. The main stage in the contact process is an equilibrium reaction. SO2 reacts with oxygen and forms SO3. Which row describes the effect of the named condition on the equilibrium yield? So now we have to find out whether the yield of this chemical reaction is increasing or decreasing or remaining the same. First one is the presence of catalyst. So as we know that catalyst only reduces time. It does not have any effect on the yield of the product. Second is pressure. As in this chemical equation, all the reactants and product is in the gaseous form, so it means that there will be an effect of pressure. So finding the number of moles, there are 2 number of moles of sulfur dioxide and 1 number of mole of oxygen on the reactant side, and we have 2 moles of sulfur trioxide on the product side. So overall there are 3 number of moles on the reactant side and 2 number of moles on the product side. As we know that if the pressure is increased, then the reaction moves in the forward direction. Because whenever the pressure is increased, the equation moves from more number of moles to less number of moles. As the number of moles of reactant is 3 and the number of moles of product is 2, so the reaction will move in the forward direction. So it says high pressure, so it should increase the yield. Third one is high temperature. Now in contact process, this chemical reaction is exothermic because the enthalpy change is negative. So temperature, you have to remember this point that whenever we increase the temperature for exothermic reaction, the reaction goes backward, while for the endothermic reaction, the reaction goes forward. Or we can say that for the exothermic reaction the yield is decreased, and for the endothermic reaction the yield is increased. In this case we have exothermic here, so the yield will decrease. So the answer is part B. Question number 12. X and Y are the oxides of period 3 elements. If 1 mole of X is added to water, the solution form is neutralized by exactly 1 mole of Y. So you have 1 mole of X, the reaction with water, and it is neutralized by 1 mole of Y. So we have to solve it for all of these. So the first one is P4O10. X is P4O10. So if we dissolve it in water, it forms phosphoric acid H3PO4. Now balancing this chemical equation, we have 4 phosphorus atoms on the reactant side, so we can balance the number of phosphorus atoms. Now we can also balance the number of hydrogen atoms, 12 hydrogen atoms on the product side, so we have 12 hydrogen atoms. Now we see whether it could be neutralized by 1 mole of Al2O3 or not. For H3PO4 plus aluminum oxide it forms aluminum phosphate along with H2O. Now balancing this chemical equation, we have 4 number of moles of H3PO4. So it means we have 4 phosphate ions. So just balancing the number of phosphate ions, we can write 4 on the product side. Now aluminum is 4 on the product side, so we can write 2. Now there are 2 aluminum on the reactant side. In the last, balancing the number of oxygen and hydrogen atoms, we have 6 H2O. So now we can see that 1 mole of P4O10 produces 4 moles of H3PO4, and 4 moles of H3PO4 require 2 moles of aluminum oxide. While in the question it says there should be 1 mole of Y. So it means it is not A. Coming to part B. SO3 reacts with water to form sulfuric acid, H2SO4. Now sulfuric acid reacts with aluminum oxide and it forms aluminum sulfate. Now we can see the ratio. Balancing this chemical equation, the ratio in the first one is 1:1. Balancing the second chemical equation, we have 3 sulfate ions in the product side, so we can write 3 with H2SO4. There are 6 hydrogen atoms on the reactant side and it is balanced by writing 3 with H2O. Now we can see that 3 moles of sulfuric acid require 1 mole of aluminum oxide. As 1 mole of sulfur trioxide produces 1 mole of sulfuric acid, so it means 3 mole of sulfuric acid will be formed from 3 moles of sulfur trioxide. So the ratio is not 1:1. So B is also wrong. Now coming to part C. Part C has P4O10. So the equation is similar. Now 4 moles of H3PO4 are formed. It reacts with Na2O. And the product is sodium phosphate and H2O. Now balancing this chemical equation, we have 4 phosphate on the reactant side, so we can write 4 with the product in order to balance the phosphate ions. Now the number of sodium atoms on the product side is 4 into 3, 12. So we can write 6 to make it 12. So again the ratio is 4:3. The ratio is 4:6 or 2:3. Again it is not 1:1 ratio, so C is also wrong. Now coming to part D, we have sulfur trioxide which reacts with water to give sulfuric acid, and the ratio of reactant and product is 1:1. Now H2SO4 will react with sodium oxide and form sodium sulfate along with water. Now balancing this chemical equation, we have one sulfate ion, two sodium atoms, two hydrogen, one oxygen, two hydrogen, one oxygen. So now the ratio comes to be 1:1. So it means that the answer is part D. Question number 13. Compound Z is insoluble in water but soluble at low pH. What could be compound Z? Number 1 is barium carbonate. Number 2 is barium chloride. So first we see what are the properties of barium carbonate. So barium carbonate is basically insoluble in water, but it is soluble in acids. So acids basically means low pH. For example, if barium carbonate is dissolved in hydrochloric acid, it forms barium chloride plus water plus carbon dioxide, and barium chloride is water soluble. B part is barium chloride. Yes, it is soluble in water. Barium hydroxide, it is also soluble in water. Barium sulfate, it is insoluble in water. Or acids. So the answer is part A. Question number 14. Hot aqueous sodium hydroxide reacts with chlorine. Which statement is correct? Number A. The oxidation numbers of chlorine and hydrogen both change in the reaction. The oxidation numbers of chlorine in the products are -1 and +1. So let's see what are the oxidation states. Sodium is +1, oxygen is -2, hydrogen is +1, chlorine is 0 because it is neutral. Again sodium is +1, chloride ion is -1, sodium is +1. There are 3 oxygen atoms, so the overall charge is -6. So the positive charge should be +5. Water, oxygen is -2, so hydrogen is +1. Again there are 2 hydrogen atoms, so each hydrogen atom has +1. The oxidation numbers of chlorine and hydrogen both change. We see chlorine changes from 0 to -1 and 0 to +5. While the oxidation state of hydrogen is +1 on the reactant side and +1 on the product side. So both does not change, only oxidation number of chlorine is changing. So A is incorrect. B is the oxidation numbers of chlorine in the products are -1 and +1. It is, as we can see in sodium chloride, it is -1, but in sodium chlorate it is +5. So it is not +1, it is +5. So this is also wrong. C part. If the aqueous sodium hydroxide is cold, the reaction produces NaClO instead of NaClO3. Yes, this is correct because chlorine, when reacts with cold sodium hydroxide, it produces sodium chloride along with NaClO and H2O. So C is correct. D. Sodium undergoes disproportionation in this reaction. Disproportionation basically means self-oxidation reduction. So in this reaction, basically chlorine is getting oxidized and reduced. So it is not sodium, it is chlorine. Question 50. Solid ammonium nitrate is put into a test tube and solution X is added to it. The resulting mixture is warmed and the gas given off is tested with damp red litmus paper. The litmus paper changes from red to blue. What could be the identity of X and its role in this reaction? So let's see. In order to solve this question, you should know about one chemical reaction. Always remember that ammonium salt plus alkali, it always produces ammonia gas. Any ammonium salt, when reacts with alkali, it produces ammonia in the form of gas. Second point is that ammonia is basic in nature, so base turns red litmus to blue. And third point is that according to Bronsted-Lowry concept of acid and base, base is proton acceptor. So considering these 3 points, the answer is part B. Because sodium hydroxide, it reacts with ammonium nitrate to form ammonia gas, and ammonia gas turns red litmus to blue. And sodium hydroxide is a base, so yes, it is a proton acceptor. Question 16. Sodium, magnesium and aluminium are 3 elements in the period 3 of the periodic table. Each element forms an oxide. Which row is correct? So first one is A, sodium oxide, it is basic. Yes, metal oxides are basic in nature. Magnesium oxide, it is also basic in nature, so this is wrong. Aluminum oxide is amphoteric, this is correct. Now the structure of sodium oxide is giant ionic. Yes, it is an ionic compound, so the structure is giant ionic. Similarly, magnesium oxide is also an ionic compound, so the structure is giant ionic. Aluminum oxide is also a giant ionic compound, so this is wrong. Simple molecular is wrong. Now sodium oxide has a high melting point. Obviously, when the structure is giant ionic, so the melting point should also be high. Same for magnesium oxide, the melting point is high. But it says a low melting point, so this is wrong because aluminum oxide is also giant ionic and the melting point is very high. Now the fourth point is sodium oxide readily reacts with water. Yes, it reacts with water and produces sodium hydroxide. Magnesium oxide, slight reaction with water. Yes, it is correct, and it forms magnesium hydroxide with water. Aluminum oxide has no reaction with water as it is stable to the dissolution or reaction with H2O. So the answer is part D. Question 17. A student investigates calcium nitrate crystals by heating them in the apparatus. So he is heating calcium nitrate. A colorless gas leaves the apparatus at Y. A flame is held to this gas. Which observations would the student make? So first of all, we will see how the thermal decomposition of calcium nitrate goes. So calcium nitrate is decomposed when heated to produce calcium oxide, nitrogen dioxide, and oxygen gas. Now about NO2, we know that this is toxic gas and it is also brown in color. While oxygen, it helps the flame. NO2 also dissolves in water to form acid, nitric acid, NO2 plus H2O, it gives HNO3. The property of acid is that acid turns blue litmus to red. So from these points we can find out the answer. First one is litmus solution. So litmus solution changes to blue or changes to red. So it should be changes to red. And also oxygen gas is also formed as the product. So the flame burns more brightly. So the answer is part C. Question number 18. How does concentrated sulfuric acid behaves when it reacts with sodium chloride? So let's write the chemical equation. We have sulfuric acid and sodium chloride. It will give sodium sulfate and HCl. Let's find out the oxidation states. So the oxidation state of sodium is +1, chloride is -1, sulfur is +6, +6, +1, -1. Sodium is also unchanged, oxygen is also unchanged, hydrogen is also +1. So the concentrated sulfuric acid behaves as an acid only. Yes, it is true. It acts as an acid and oxidizing agent. So we can see that sodium is not oxidized. The oxidation state of sodium is unchanged. Oxidation state of chloride and sulfur is not changed, so it is wrong. So it neither behaves as oxidizing agent nor reducing agent. It only behaves as an acid. So the answer is part A. Question number 19. Which statement about nitrogen or its compounds is correct? Part A. In the Haber process, the temperature is kept high to give a good equilibrium yield of ammonia. Now we know that the Haber's process is exothermic, so the energy is negative. The temperature is kept high to give a good equilibrium yield. This is wrong. The temperature is kept high in order to keep the pace of the reaction at optimum speed. Because in exothermic reaction, whenever you increase the temperature, the reaction goes backward and the yield is actually decreased. So part A is wrong. B. Nitrogen gas is unreactive. Yeah, it is unreactive because of the strong nitrogen-nitrogen double bond. As nitrogen is in group 5 of the periodic table, so it makes 3 bonds with itself. So it is not a double bond, it is a triple bond. So B is also wrong. Part C says nitrogen monoxide will react with carbon monoxide under suitable conditions. So if we have NO and CO, this reaction takes place in the catalytic converter. So it converts into nitrogen and carbon dioxide. So yes, under suitable conditions, given proper catalysts, this reaction is possible. D. The formula of ammonium sulfate is NH4SO4. As we know that the charge on ammonium ion is +1 and on sulfate is -2. So the formula should be ammonium 2 sulfate. So D is wrong. So the correct answer is C.
Question number 20. Which pair of compounds are functional group isomers of each other? Now, what is a functional group isomer? Functional group isomers are basically those compounds that have the same molecular formula but different functional groups involved. Let's see the answers. Part A says butane, 1-ol and butanol. This is butane, 1-ol. Butane consists of 4 carbon atoms and OH is attached to the first carbon. Butanol also consists of 4 carbon atoms and the functional group is aldehyde. Now let's see the number of hydrogen atoms on each of them. This one has 3 hydrogen, 2 hydrogen atoms, 2 hydrogens, 2 hydrogens. This carbon has 3, this has 2, this has 2. Now the total number of hydrogens in butanol and butanol is 3, 4, 5, 6, 7, 8, 9, 10. 10 with alcohol and 8 with aldehyde. So it means they are not isomers. B is ethyl propanoate and pentanoic acid. Let's draw the structures of ethyl propanoate. This is ethyl propanoate. This one is pentanoic acid. Now let's draw the number of hydrogens with each. 3, 2, 2, 3, 3, 2, 2, 2. So this one has 10 hydrogen atoms. This one has 10 hydrogen atoms. Both have 5 carbon atoms each, 2 oxygen atoms. So it means that they are functional group isomers because the functional group in both of them are different. One is ester and the second one is carboxylic acid. Now let's see how part C goes. It says hex 1-ene and hex 2-ene. So hex 1-ene means that the double bond is with in between first and second carbon atom. This is hex 1-ene. And hex 2-ene means that the double bond is in between carbon 2 and carbon 3. As the functional group in both of them are same, so they are not functional group isomers, they are actually same alkene compound.
D is propylamine. And propane nitrile. As you can see, the number of hydrogens are not equal, so therefore they are not the isomers of each other.
Question number 21. Which row identifies a suitable starting material and reagent that can be used to produce butane nitrile? So we have to take two things. One is starting material and second is reagent. Let's see what is butane nitrile. So butane means we have 4 carbon atoms and nitrile means that we have 1 nitrogen atom present. So in order to make butane nitrile with a cyanide reagent, we need starting material of 3 carbon atoms. So the starting material must be of 3 carbon atoms because the 4th carbon is introduced by cyanide. So it could be A or it could be B, because A has 3 carbon atoms and B also has 3 carbon atoms. Then we have to find out the reagent, whether it should be HCN or NaCN. So why do we take NaCN and why shouldn't we take HCN? Actually, for this reaction, ethanolic NaCN is used. HCN is not used because HCN is poisonous, and also its dissociation power is very low. It is barely dissociated into ions, while NaCN dissociates into Na plus and Cn minus readily. So therefore the answer should be NaCN. So the answer is part B.
Question number 22. The diagram shows the structure of ethane dioic acid. It means it has got 2 carbon atoms and 2 carboxylic acid groups are present. Ethane dioic acid reacts with ethanol. Ethanol is CH3, CH2, OH. In the presence of few drops of concentrated sulfuric acid to form a diester. So 2 esters are formed, one on each carboxylic acid functional group. The molecular formula of the diester is C6H10O4. What is the structural formula of the diester? So let's see how this compound reacts. So first I'm going to draw ethane dioic acid. OH on each side, and we have carbon double bonded with the oxygen atom. Now let's take ethanol on both sides. CH3, CH2, OH, and similarly we are going to draw an opposite one, OH, HO, you can say CH2 and CH3. Now what happens when carboxylic acid and alcohol, they react with each other? A water molecule is eliminated. So this is a water which is eliminated. So there are 2 molecules of water that are eliminated, and the rest of the compound is CH3, CH2, O, then we have carbon, then double bond O, then carbon, then again double bond O, then oxygen, then CH2, and then CH3. So what is the structure formula of the diester? Part A says CH3, CH2, CO2. This is not CO2, this is OCO. Part B, it writes OCO, and then we have CO2. OCO, and then we have CO2. So yes, part B is correct. Part C says O2, which is wrong. Part D has CO2 on the second place, which is also incorrect. Question number 23. The infrared spectrum shown was obtained from a compound J. So this is the infrared spectrum. We can see that the peaks coming are in between 1600 and 1700 per centimeter, and also between 2800 to 3500. Which statement about J is correct? Now we can see that in all 4 parts A, B, C and D, only 2 different functional groups are given. One is carbonyl and second is carbon triple bonded with nitrogen atom. So let's see what is their values in the function in the data booklet. So from the data booklet we know that carbonyl carbon comes between 1640 and 1750 with a strong peak, while CN comes in between 2200 to 2250 per centimeter, and the peak is wide. Now this region is between 16 to 1700 degrees per centimeter. So it means yes, carbonyl is present because this shows the strong peak between 16 and 1700. So carbonyl is present, while CN there is no peak between 2200 and 2250. So we can say there is no peak here. So it means carbonyl is present but CN is not present. So the answer is part C. Question number 24. A section of a polymer chain is shown. What is the correct monomer? So from this chain we have to find out the monomer. First let's find out the repeat unit. As we know that the bond that is coming out of this square bracket is double bond in the monomer. Similarly, this bond was also the double bond when it was a monomer. Now let's find out the repeat unit. So if this was a double bond, then we have one carbon here, second one which is not shown, and again these two carbon must have double bond between them, and then these two carbon atoms must have a double bond between them, and then again this carbon and the carbon which is not shown had a double bond. So let's find out the repeat unit. We can take out the repeat unit. So this is one unit. This is another repeat unit. Let's draw it separately. It is like this. One bond is continuing like this and second bond is continuing like this. So in order to make a monomer, we have to make a double bond. Now this is the repeat unit and this one is monomer. Now in this monomer we can see that the one carbon which is doubly bonded has a methyl group, CH3 group attached, while the second carbon has ethyl group, CH3CH2, and also isopropyl group, CH3CH2 as 3 group. Now let's see which is the answer. So in part A, if this is the double bonded carbon atom, we have one methyl group, and with the other carbon atom we have propyl group and ethyl group. So yes, this one seems to be the answer. Let's see B part. We have methyl group and there is also ethyl group with the same carbon atom, which is wrong. Then on the C part, we have ethyl groups on both sides of the double bond, which is also wrong. In D part, we have methyl and propyl group on the same side, which is wrong. There should be ethyl and propyl group on the same side. So the only structure which is correct is A. Question number 25. Structural isomerism and stereo-isomerism should be considered when answering this question. How many non-cyclic isomers? So all we have to draw are the non-cyclic isomers. Have the molecular formula C5H10. So let's find out. C5H10 means it is an alkene because the formula is CnH2n. So this alkene has 5 carbon atoms. Let's draw the double bond on the first carbon atom. As we know that there are 2 hydrogen atoms with the corner carbon, so the name is pent-1-ene. And there is no cis-trans isomer. Because with the double bonded carbon atom, there are 2 hydrogen atoms. The atoms with the double bonded carbon must be different for a geometric isomerism. Now let's draw another one. Let's take double bond to the carbon 2. This is pent-2-ene, and cis and trans both are possible for this one. Because the doubly bonded carbon has 2 different atoms attached directly with it. Let's draw the third one. Again I am taking pent-1-ene and I am changing the long chain. So this will be 3-methyl-but-1-ene. This is first carbon, this is second, this is the third one. Again, stereoisomer is not possible because corner carbon has 2 same atoms attached with it. So no cis-trans. Let's move this substituent to another place. So we have CH2 double bond C. Now the name of compound is 2-methyl-but-1-ene, and again no cis-trans is possible. We can move double bond to the next carbon atom. It will be something like this. This is 2-methyl-but-2-ene. Again, no cis-trans isomers because the double bonded carbon has same atoms attached. Now counting, this is the first structure, this is the second one with cis, and third one with trans, this is the fourth one, this is the fifth one, and this is sixth. So we have 6 non-cyclic isomers that are possible. So it means that the answer is D. Question number 26. An excess of dry HBr is warmed with compound Y. What is the major product of this reaction? Now let's see what does dry HBr do.
First reaction is that it can replace OH of primary alcohol. HBr can also be added to alkene. Now the addition to alkene should be according to Markovnikov rule. Markovnikov rule says that hydrogen of HBr goes to the carbon atom having more number of hydrogen atoms. So let's see how many hydrogen atoms are present on each carbon atom. This has no hydrogen atom because all 4 bonds are made. This one has 1 hydrogen atom. This carbon does not have any hydrogen atoms. This has 2 hydrogen atoms. And this is OH of primary alcohol. So HBr will replace this OH with Br, and according to Markovnikov addition we should have Br over here and H on this carbon. Similarly, according to Markovnikov addition, Br must be here and hydrogen on this carbon atom. Let's see which answer is correct. We have OH unchanged, so this is not the answer. We have OH unchanged, no. This one is replaced by bromine, so yes, this is good. This bromine is attached to this carbon atom, it is also correct. This bromine is attached to this carbon atoms, it is also correct. So the answer should be part C. In part D we can see this one is correct, while the position of bromine should not be here. It should be on the other carbon atom according to Markovnikov rule. So therefore this is wrong. Question number 27. Which reactions would produce propanoic acid as one of its products? So there are 4 different types of reactions, A, B, C and D. Let's solve each of them in detail. First A, heating with concentrated acidified KMnO4. So we know that when concentrated acidified KMnO4 is used, it will break the double bond and oxidize each of the sides. So one of the side will be converted into ketone while the other one is converted into aldehyde. First one becomes ketone and second becomes aldehyde. Now as it is concentrated, second one becomes aldehyde. Because of the concentrated KMnO4, this aldehyde won't stop. It will be further oxidized and converted into carboxylic acid. Now let's find out the names. This one is propane 2-one. This one is propanoic acid. The question said that which reaction would produce propanoic acid as one of its products. So one product is propanoic acid. So part A is the possible answer. Now let's see part B. Part B says heating. This is ester with aqueous sodium hydroxide. So it is hydrolysis of ester in the presence of aqueous sodium hydroxide. This is propyl propanoate. And in the presence of aqueous sodium hydroxide, it will be hydrolyzed into sodium propanoate and propanol, or you can say propane 1-ol. So neither of the product is propanoic acid, so B is not the correct option. Now let's see part C. It says heating ethanol with acidified potassium dichromate under reflux. As this is ethanol, it will be oxidized to aldehyde. So ethanol to ethanol. Neither of the product is propanoic acid, so C is also incorrect option. Part D says reacting ethanol with HCN and then heating the organic product with sulfuric acid. So let's see what happens when aldehyde reacts with HCN. One carbon atom will be increased. Now what will happen that it is converted into hydroxynitrile. A double bonded oxygen hydrogen is going to be attached and with other carbon atom cyanide. This is ethanol, this is hydrogen cyanide, this one is 2-hydroxy propane nitrile. Nitrile is because of the presence of carbon triple bond nitrogen. Now this is further reacted with sulfuric acid. So in the presence of aqueous sulfuric acid, the following product is formed: CH3 OH, and CN is converted into carboxylic acid group. What happens to the nitrogen atom is that it forms ammonium sulfate with sulfuric acid. So none of the product is propanoic acid. The name of this compound is 2-hydroxy propanoic acid. So therefore D is also incorrect. So the only answer is part A. Question number 28. Compound X is treated with an excess of lithium aluminum hydride. The reaction is allowed to go to completion. What is the structure of the organic product formed? What is lithium aluminum hydride? It is LiAlH4 and it is a powerful reducing agent. So what does lithium aluminum hydride does? So what does lithium aluminum hydride do? We have ketone in our given structure. So ketone is reduced to secondary alcohol. While on the other side of this compound we have carboxylic acid. Carboxylic acid will be reduced to primary alcohol. So COOH is reduced to primary alcohol. Let's see which of these four options are correct. So in part A they haven't changed the ketone, so this is wrong. In part B ketone is not changed. In part C ketone is converted into secondary alcohol, this is correct. But the carboxylic acid remains as it is, so it is wrong. Now part D, secondary alcohol and primary alcohol. So the answer is part D. Question number 29. What is the skeletal formula of the compound formed when this compound is heated under reflux with potassium dichromate in the presence of acid? So let's see what have they given to us. CH3, C double bond, C, CH2, OH. So we have primary alcohol and we also have a double bond, alkene. Now potassium dichromate is oxidizing agent. It oxidizes primary alcohol to aldehyde and aldehyde further to carboxylic acid. While alkene is not affected by potassium dichromate, so only this portion must be converted into carboxylic acid. Let's see which part is correct. So in part A they have converted into aldehyde, which is wrong because it won't stop at aldehyde, it will convert into carboxylic acid. Part B they have converted into carboxylic acid and alkene is unaffected, so it means it is the correct option. In part C they have changed the alkene, which is not possible. In part D they also have changed the alkene, which is not possible. So the only possible answer is part B. Question number 30. The diagram shows the structure of compound Q. Two of the rings X and Y contain a carbon-carbon double bond. Which row is correct? Now the first column says number of ester groups in one molecule of Q. How many ester groups are there? Well, let's see what is ester. The functional group of ester is RC double bond OOR, where R is the alkyl group and C double bond OO is the central functional group. So let's see how many C double bond OO are present. There is this one and then we have this one. So 1 and 2. We have two number of ester groups. So it could be C or D. Second part is description of rings X and Y. Both are planar or neither is planar. Let's see what type of hybridization occurs in X and Y. There are two types of carbon atoms in X, some having carbon-carbon single bonds and the others with carbon-carbon double bond. The same is the case with Y ring. So the carbon atoms making single bonds are actually sp3 hybridized, while the carbon atoms making double covalent bond are sp2 hybridized. If in
one ring, sp2 and sp3, both type of hybridization are present, then it means that it is not planar. While if all the carbon atoms are of sp2 hybridization, then the ring could be planar. For example, in benzene we have a planar ring because all the carbon atoms are sp2 hybridized. So we can say neither is planar, so the answer is part D. Question number 31. Carbon and nitrogen are adjacent in the periodic table. Which properties do they both have? 1. There is an empty 2p orbital in each atom of the element. So let's find out the electronic configuration of carbon and nitrogen. The atomic number of carbon is 6, so it will be 1s2, 2s2, 2px1, 2py1, 2pz, no electron. Now nitrogen is 7, 1s2, 2s2, 2px1, 2py1, 2pz1. So there is an empty 2p orbital in each atom. No, there is an empty orbital in carbon but not in nitrogen. First is wrong. The principal quantum number of the highest occupied orbital is 2. We can see that the highest occupied orbital is 2 in carbon case, and it is also 2 in nitrogen case. So it is correct. They can form compounds in which their atoms form 4 bonds. We do have an example for carbon atom. We know that carbon can make CH4, which is methane, and carbon atom is making 4 single covalent bonds. While for nitrogen, we know of a compound names ammonium ion. In ammonium ions, nitrogen is also making 4 bonds. 3 of them are covalent and 1 is coordinate covalent bond. This one is correct. So we have options 2 and option 3 correct. So the answer is C. Question number 32. The strong hydrogen bonding present in liquid water causes an increase in which properties? Number 1, viscosity. Viscosity is actually the resistance of a liquid to flow. So higher the hydrogen bonding, more will be the viscosity. So yes, stronger hydrogen bonding will increase the viscosity. Now boiling point is actually the temperature at which intermolecular forces are broken, which is actually hydrogen bond. So higher the hydrogen bonding, higher will be the boiling point. Third one is surface tension. If there is extensive hydrogen bonding present, then the surface of the liquid will be more tense because of the attraction from the water molecules present in the lower layers. So yes, all of them are correct. So we can say 1, 2, 3, and the answer is A. Question number 33. A reaction between carbon and oxygen is shown. This is the chemical reaction. Carbon and oxygen, they are forming carbon monoxide gas. How can the standard enthalpy change of this reaction can be described correctly? Now one says standard enthalpy change of formation. Now what is enthalpy change of formation? It is enthalpy change when 1 mole of a compound is formed from its element in standard state under standard conditions. So yeah, this is fulfilling the equation because 1 mole of carbon monoxide is being formed from carbon and oxygen, and both are in their elemental states. So yeah, this could be the enthalpy change of formation. Second is the enthalpy change of combustion. The enthalpy change of combustion is basically when 1 mole of a substance is burnt in excess oxygen. Now in this equation you can see that oxygen is not in excess, but actually only 0.5 moles of oxygen gas are given.
That's why it is not properly combusted and carbon monoxide is formed instead of carbon dioxide. So it is not enthalpy change of combustion. Third is the enthalpy change of atomization. In enthalpy change of atomization, 1 mole of gaseous atoms is formed from its elements under standard conditions. So in this equation there are no atoms, but actually carbon monoxide is formed, which is a molecule. So this is also wrong. We just have one option, which is 1. So the answer is D. Question number 34. Hydrochloric acid reacts with zinc. So acid plus metal gives salt and hydrogen gas. What will increase the rate of this reaction but will not change the Boltzmann distribution of molecular energies? So we know that the Boltzmann distribution of energy is actually affected by temperature only. It is not affected by catalyst. Part 1. Addition of a suitable catalyst. Yes, catalyst reduces the time taken in order to make the product, so therefore it increases the rate of reaction. Second one is an increase in concentration of hydrochloric acid. Yes, we know higher the concentration, more will be the rate of reactions, so it also increases the rate of this reaction. An increase in temperature of hydrochloric acid. So temperature also increases the rate, but temperature also affects the Boltzmann distribution of energies. So therefore we will omit part 3. Only 2 will be left behind, 1 and 2. So the answer is B actually. Question number 35. The element astatine is below iodine in group 17 of the periodic table. Which statement concerning astatine are likely to be correct? Number 1. It is a dark colored solid at room temperature. Yeah, we know for the group 17 that the elements become darker down the group. Number 2. It is a more powerful oxidizing agent than iodine. For halogens, we know that the oxidizing power decreases down the group. So this is not the case. Actually, iodine is more powerful oxidizing agent than astatine. 3. Its hydride is more thermally stable than HBr. Now, stronger the bond between hydrogen and halogen, it will be more thermally stable. So we know that the bond strength decreases down the group. HF has the highest bond strength, then HCl, then HBr, then HI, and astatine is in the last. So it is not more thermally stable, it is actually less thermally stable than HBr. So the only option which is correct is 1. So the answer is D. Question number 36. Which statements are correct? Number 1. Aluminum chloride dissolves in water to give an acidic solution. So when aluminum chloride is dissolved in water, it forms aluminum ion and chloride ion. Now aluminum ion form coordination compound with water molecules. So it will be basically like this: AlH2O 6 and +3 charge for aluminum atom. So now this is also dissociated. This compound forms Al. One of the water molecules is dissociated, so 5 water molecules are left behind, and the water molecule which is dissociated, it forms OH negative and H positive. Now as we have -1 charge on the inside, so the total charge is changed to +2. So because of the presence of this H plus ion, the solution becomes acidic in nature. So it says aluminum chloride dissolves in water to give an acidic solution. So
So yes, this is correct. Number 2, magnesium chloride salt dissolves in water to give a solution of pH close to 7. As we know that magnesium chloride does not react with water, it is just converted into ions, magnesium ions and chloride ions. So there is no effect on the pH. So this is also correct. Now the third one says sodium chloride dissolves in water to give an alkaline solution. Now sodium chloride behaves exactly like magnesium chloride, only the ions are formed and there is no change in pH. So it does not give an alkaline solution, it actually gives a neutral solution. So only 2 options are correct, 1 and 2, and the answer is B. Question number 37. Ethanol and hydrogen cyanide react together. The reaction mechanism involves cyanide ions. This is the reaction mechanism. The question says which statements about this mechanism are correct. Number 1, Cn- acts as a catalyst. What is the definition of a catalyst? Catalyst is something that is reformed at the end of a reaction without being used up, or it also increases the rate of chemical reaction. We can see cyanide ion present in the reactant side and also formed in the product. So yes, it is behaving as a catalyst because it is not involved in the chemical reaction. Cyanide ion is a nucleophile. Now nucleophile is something that has negative charge or lone pair of electron present. We can see in cyanide ion there is a lone pair and also a negative charge. So yes, cyanide ion also acts as a nucleophile. Third one is an addition reaction. It is an addition reaction. Let's see whether something is added or not. So we had HCN and this is the reactant. So HCN is added into the reactant and double bond is converted into single bond. So yes, it is the example of addition reaction. So all 3 are correct, which means that the answer is A. Question number 38. Which compounds will produce a yellow precipitate with alkaline aqueous iodine? Now this is a factual question. You must remember that alkaline aqueous iodine gives yellow precipitate with 3 types of compounds. So it gives positive result with number 1, if you have methyl ketone, that is CH3 C double bond O R. So on one side of the ketone there must be a methyl group present. Second is ethanol, CH3 C double bond O H. So this one gives positive result with aqueous iodine. Third one is with the secondary alcohol group. So we have CH3 COH and R. If these 3 types of compounds are present, then always a yellow precipitate is formed. So let's see which one of these is present in the given compounds. Number 1, this is carbon atom. So this OH is tertiary because this carbon atom is further combined with 1, 2, 3 other carbon atoms. So tertiary does not give positive result. On the other side we have aldehyde, which does not have any methyl group. So this is unable to give the precipitate. Let's see the second one. We have OH group attached to this carbon atom and this carbon atom is further attached to 2 other carbon atoms, so it is secondary alcohol. Yeah, it can give positive result. Now going to the third one, we have
secondary alcohol. Yeah, this one gives positive, and this one is tertiary alcohol. It does not give positive result. So it means compound 2 and compound 3 will give yellow precipitate with aqueous alkaline iodine. So the answer is C. Question 39. Which statements apply to tetrafluoromethane? So tetrafluoromethane is basically carbon bonded with 4 fluorine atoms. Let's see the options. Number 1, it is rapidly decomposed by ultraviolet radiations. Now CF bond is present in tetrafluoromethane, which is a very strong bond, so it is not easily decomposed by UV radiations. Number 2, it is less harmful to the ozone layer than dichloro-difluoromethane. Dichloro-difluoro means there are 2 fluorine atoms and 2 chlorine atoms. If the chlorine atoms are present, then in the presence of UV light, chlorine radical is formed easily. So therefore CF4 is less harmful than CF2Cl2. So part 2 is correct. Third one says it is a non-polar molecule. So let's see. Fluorine is attached with carbon atom on all 4 sides as it is a tetrahedral structure. Third option says it is a non-polar molecule. So let's see, carbon combines with 4 fluorine atoms and the structure is tetrahedral and bond angle is 109.8. So now all 4 fluorine are electronegative and the dipole moment of this molecule is going to be 0 because it is attracted from all 4 sides equally. So dipole moment is 0, so therefore this molecule is non-polar. So it is correct. So we have option number 2 and option number 3. It means the answer is C. Question number 40. Which statements comparing ethene and ethane are correct? Number 1. The bond angles in ethene are larger than the bond angles in ethane. Let's draw the structure of ethene molecule. And the structure of ethane molecule. Now we can see that the bond angle here is 120 degrees because there are 3 bonds, one double bond, this one single sigma bond, this one is also single sigma bond. So overall in 360 degree space the angle is 120 degrees. While in ethane carbon atoms make 4 single covalent bonds, so the structure is tetrahedral and the bond angle is 109.8 degrees. So the bond angle in ethene is larger than the bond angle in ethane. So this one is correct option. Second says ethene reacts much more quickly with bromine in the dark than ethane does. So ethene when reacts with bromine, what happens that the bromine actually converts the double bond of ethene into single bond and each double bonded carbon atom has now bromine atom. Now ethane does not react with bromine in the dark because ethane is a saturated compound and saturated compound does not add something else in it. Ethane only reacts when light is present because light makes the bromine radical, which then substitutes the hydrogen atom present in the ethane. So therefore B is, second part is true. Now part 3, complete combustion of 0.01 mole of ethene or ethane produces the same volume of gas. Now this is a question of moles. Let's find out the number of moles of the gas formed or the volume of gas formed. The reaction of ethene with oxygen. Ethene is C2H4. It reacts with oxygen to give carbon dioxide and water molecules. As in the question, it says that measured at room temperature. So when there is room temperature, then water molecules will be converted into liquid form. So the only gas that is left is carbon dioxide gas. Let's balance out this chemical equation. We have 2 number of carbon atoms on the reactant side, so 2 number of carbon atoms now on the product side. And then we have 4 hydrogen atom on the reactant side. Let's balance the number of hydrogen. Now there are 6 oxygen atoms in the product, so we can write 3 with oxygen atom. So if we have 1 mole of ethene, then 2 moles of carbon dioxide are formed. So if we have 0.01 mole of ethene, then 0.02 moles of carbon dioxide are formed. We can also change this into volume. Just multiply 0.02 into 24 decimeter cube. So it is 0.48 decimeter cube gas. Now let's carry out the same reaction with ethane. Ethane is C2H6 plus oxygen. It will give carbon dioxide, water molecule. Water molecule will be liquid, only the gas is carbon dioxide. Let's balance the chemical equation. We again have 2 moles of carbon and 3 moles of hydrogen. Now 4 and 3 7, you can write 7 by 2. Now we can see 1 mole of ethane produces 2 mole of carbon dioxide, so 0.01 mole of ethane will produce 0.02 mole of carbon dioxide, or when converted into volume it will form 0.48 decimeter cube, which is the same as compared to ethene. So third part is also correct. So we have 3 options, 1, 2, 3. So the answer is A. Thank you for watching. If this video was useful, please drop a like and do subscribe to this channel for similar upcoming videos. See you in the next one. Till then, stay happy. Peace out.